Good morning. I am Padmapriya Padmanabhani. Now I would like to present my embedded systems project titled Washing Machine Simulation using PIC16F877A. This project was done as a part of my internship program under the Emertxe Embedded Systems in this month. Under this, I developed a project using MPLAB XIDE, XC8 Compiler and PICSimLab tools. So these are the necessary tools that we have to use to make this project. Introduction to embedded systems. Embedded systems are specialized computing systems that are designed to perform the dedicated task. Unlike general purpose computers, they are built into devices and control their functions. They consist of a microcontroller, memory, and input-output components. So embedded systems are found in almost every field, from consumer electronics to industrial machinery. So these are very necessary. In our daily life, we use the embedded systems. Next is applications of the embedded systems. Embedded systems are everywhere around us. In homes, they power washing machines, ovens, microwave ovens, and smart appliances. In vehicles, they control airbags, ABS, and engine functions. They are also used in medical devices like pacemakers, ventilators, and also in IoT based automation systems. Not only this, apart of them, there are many other applications. There are lot of applications that we are using, like industrial robots, GPS receivers, digital cameras, DVD players, MP3 players, photocopiers, wireless routers, set-top boxes for TV, and gaming consoles, etc. Next is, what is embedded C? So this embedded C is also similar to the C programming. Here we use it for developing the projects for microcontrollers, using microcontrollers. So embedded C is a programming language used to write the software for microcontrollers. It extends the standard C language with features to control the hardware. It allows us to interact with registers, ports, and memories directly. Embedded C is highly efficient and suitable for real-time applications like this project. So it is necessary to learn the C programming and update it with learning embedded C. Nextly, about PIC16F877A microcontroller. This is a 8-bit microcontroller by Microchip technology. This microcontroller has 40 pins, out of which 33 are programmable input-output lines. It comes with the features and built-in peripherals like timers, ADC, PWM, USART, 8 KB flash. And this is ideal for the both real-time embedded systems projects and simulations. So here in this project we have used this microcontroller for our convenience. It is useful for the beginners as well. So we have used it. Objective of the project. The main objective of my project was to simulate a basic washing machine controller. It has basic features of the washing machine. In order to show the demo, I have made it. The washing process includes the multiple phases like start, wash, rinse, and spin. The main aim was to write the code in the embedded C to handle each phase logically. I simulated the full behavior without using the physical hardware in this PICSimLab tool. PICSimLab tool I have used instead of the real hardware. Next, tools used in the project. Here mainly I used three main tools. Mainly I used three tools. MPLAB XIDE was used to write and organize the code. and XC8 Compiler was used to compile the code and generate the hex file. Lastly, PICSimLab was used to simulate the entire circuit and washing machine behave virtually. MPLAB X IDE overview. It is an official IDE from this microchip. It is a development environment provided by the microchip. It supports various PIC and DSPIC microcontrollers. It allows writing, editing, compiling, and debugging embedded code. It also integrates smoothly with the XC8 compiler. Next one is XC8 compiler overview. The XC8 compiler is used for compiling embedded C code for 8-bit PIC microcontroller. It converts the source code into a hex file which can be loaded into the microcontroller. It provides low-level control over hardware, allowing us to configure peripherals easily. So this is mainly important where we can write the code in the MPLAB, but that code file is converted into some other hex file, .hex file. So this will be useful to load in that PICSimLab tool. So this becomes a mediator. Next one is PICSimLab overview. PICSimLab tool is an open source simulation platform that supports PIC microcontrollers. It lets us simulate circuits and peripherals without any physical hardware. I used it to test the washing machine program and simulate switches, fans, and buzzers. This was very helpful to verify my design logic. So that to make any project, initially we can use this PICSimLab tool without having the hardware. So it reduces the physical test work and cost also. Next one is peripherals used in the simulation. So in order to make this project, I have used many peripherals like tactile switches, which were used to start and stop the cycle, and a digital keypad, simulated user inputs where we can have many switches which are used to scroll and select the programs. And a fan is used. It is used to represent the drying phase. And a buzzer, which is used to indicate the phase completion, and it is also used when if you open the door while running the washing machine, it give a caution. So the buzzer used there, and a 16x4 LCD used to show the current process, where it enables us to see whatever program that we are selecting, it can be shown in the CLCD. Project flow or working. The user starts the washing machine by pressing a tactile switch. The microcontroller enters the washing state, followed by rinse and spin and dry. So each stage runs for a fixed delay using timer logic. So all the actions and feedback are handled in the code and simulated in PICSimLab. So later in a next part I will show you each and every part of working of that washing machine in the PICSimLab tool. As I said, each phase, there are 3 phases like wash, rinse, spin. So for these, the total time is divided into 3 parts for these 3 functions. Later I will show you in the PICSimLab tool while executing the program. Next one, software and hardware requirements. So for this project, I only needed software tools, MPLAB XID, XC8 Compiler and PICSimLab, as I said already many times. If I implemented this Physically, I would need a PIC16F877A board, power supply, switches, buzzer, fan, and a display module. So by using this tool, the simulation helped avoid the need for real hardware during the development. So after writing the code and compiling, finally I got the output. This is the output image. So now I'll explain the working of this washing machine demo project. Now I'll open the PICSimLab tool to show you the program running. Under this Emertxe internship program, I have done this washing machine project in embedded systems. So here we use some tools. This is the PICSimLab tool which is used to implement the project. So for this I have written the code in MPLAB X IDE. Here I have written all the codes for this washing machine program. So here are the header files and source files. And the output is built successful. Hence we can upload it in the PICSimLab and we can see the output. So for this XC8 compiler is used. So in order to run this, already I have uploaded the file. But once again I am showing you to how to load the hex file. So where the code is written, that file is loaded here. Reload last. So in this first LCD display, we get the message as press key 5 to power on the washing machine. So here are the buttons RB0, RB1, RB2, RB3 and 4, 5, 6 etc. So key 5 is RB4. So after clicking it, we get a message of powering on washing machine. After then, definitely we have many lot of types of clothes. So according to the cloth material type, we have different features given here. RB3 is the switch which is used to scroll the features or options. So here are total 12 options: daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse and dry, dry only, wash only, aqua store. After completing these 12 features, we get normally again from the beginning, that is daily wear, heavy clothes, etc. So I am selecting daily. So for selecting this, we have to long press the RB3, which is switch 4. Here it is asking water level. There are many options in this also. Water level we can keep auto, low, medium, high or maximum. So I am selecting water level as low. After selecting the features and water level, we have to start it. What's washing the clothes? So switch 5 to start the program. That is RB4. Here it is started timer and it started washing. If you want to pause in between, then you can click the switch 6, which is RB5. Here fan is running, timer is running. So if you pause it by clicking this RB5, then it becomes pause. See, timer stopped and fan is also stopped. If you want to resume it again, click the RB4, which is switch 5. So again it started running time and Sometimes during the running of washing machine we open the door, then we get the buzzer sound like this. So door is open and please close the door. We get this alarm. Until we press the switch, which is opening of the door, it shows this error. I mean caution. If you release this switch, then it indicates the closing of the door. After that, it runs again normally. Program completed. Remove the clothes. So after washing the clothes, we get that message. So this is the demo of my project which I have done during this internship of Emertxe company of washing machine under embedded systems. I have shown this code also, which I have written in the MPLAB XIDE. So this is the project. Thank you. Now in the demo of the project, I have shown you the working of that washing machine. So you can observe there, function is changing. Firstly, it comes washing, later rinse and spin. So the total time duration is divided. In that way, the washing machine project is completed successfully. So benefits of this project is, through this project, I learned how to apply embedded C in a real world context. So practical knowledge, I got it. I gained experience with all stages of development, from writing code to simulating and also debugging. So debugging is mainly very important in every application. So debugging means we should have the capacity of finding out the errors and making it correct. So I have learned it very well in this project. This project gave me a clear understanding of how microcontrollers manage automation tasks. It also improved my skills in using these professional tools. By learning this project includes the embedded C learning, so that I can use it for any other applications like micro oven, any other embedded systems. So it is very beneficial. Finally, conclusion. To conclude, this internship project helped me understand embedded systems development deeply. I simulated a complete washing machine cycle using just code and simulation tools. I am confident in applying these skills to other embedded or IoT projects in the future. I sincerely thanks Emertxe for this opportunity and guidance. Once again, I would like to say that really I am thankful to this Emertxe for teaching me everything from the scratch. They not only teach the embedded C, they started with teaching normal C programming, and later they moved to embedded C programming and shown this whole project from every point. They have cleared the doubt. So I am so thankful for this internship, so that now I can have the confidence of doing any other similar projects using this embedded C programming. And also these peripherals like tactile switches, digital keypad, fan, buzzer, LEDs, CLCD, etc. So this is the total demo of my project washing machine in embedded systems. Thank you. Thank you for watching. Thank you, Emertxe.